Hello, and welcome to another tutorial using SpaceClaim and Ansys Workbench. In this tutorial, we are going to use commercially available parts to build a cantilever hanger. Here's the hanger. It's commercially available. We'll download the IGES file. These bolts, the two bolts, as well as the two nuts, are also commercially available and have online IGES files. We'll then load the bracket and determine how the stresses propagate through this cantilevered bracket. So after opening SpaceClaim, we can go ahead and close this options window and start to sketch our drawing. I'll first build the block or the wall and then import the bracket, bolts, and nuts. I typically like to draw and sketch in the XY plane, so the first thing I will do is change the default to an XY plane. This is done by right-clicking, select New Menu Sketch, and then putting the cursor in the plane that you want to sketch in. You can see here I'm in the XY plane, and so I have an XY grid. Here I can do the ZY and the XZ. So once you've picked the sketch plane you'd like, just click on it, and then you can do a plan view and you're looking at it head on. The next step is to go to the rectangle box, click on rectangle. I want to define this rectangle about the center of the drawing, or have the coordinate system in the center. So I'll come over here and define rectangle from center. Then I come and click on the center and drag out the box. This horizontal dimension I want to be 73 millimeters, so I'll type in 73. Then I tab to the next dimension and I want that to be 131, and I hit enter. Now I have my rectangle for my block centered about my origin, and I can go ahead and enter the circles. So going to the circle, so sketch command, I come and pick a location. I want a location in the middle of my block, so I'm going to pick along the y-axis, and I click and drag this out. I want this to be 14.2875 millimeters. And now I can copy this, so I will come to the design, go to move, and click on the circle that I want to copy and move. So after this axis has come up, I get on the vertical axis to move it, and control click, and I can copy that, and I can come over here and enter the dimensions of 76.2, and that spaces my two circles in my block. They're not quite in the center, so I'm going to go ahead and select them again. So I select the top one, then control select the bottom one, and I can go to move, and I'm going to move them up and down this vertical axis. And again, they were close, but I'll move them about right there, which is a little closer. They certainly don't need to be exact for the model that I'm developing. Now that I have my plate and my two holes generated, I'm ready to turn this into a 3D body, so I can click my middle mouse button and rotate it. I'll come up to pull, click on the face and pull this body, and I want to pull it 108.5 millimeters. 108.5, enter. And so I now have my body or my wall or my block created, and I'm ready to import the truss. So I'll come to insert, and here it's nice, you can insert a standard part and look online. These two websites, when you click on them, are great websites for finding IGES files for brackets, for bolts, for nuts, for hangers, for wheels and rollers, and many other objects that you may want to use in a design or a model. I've already gone to these websites and downloaded them and saved them as IGES files, so I will go ahead and click on File and then come to the file directory where they're saved, and my bracket is saved under this directory, you'll see that you get no items match your search. So you need to come down here, and by default SpaceClaim only looks for SC.doc files. So I'll click the drop down, come over and select all files, and my IGES file in my bracket pops up, so I can click on that and click open. Now my bracket appears on my screen. There's a couple things I want to do to this before I begin to use it. I want to come over and right click on the geometry and click check geometry, and SpaceClaim checks the geometry to see if there are any errors. Then I want to click on it to activate it, and if I click again, now I have check marks, my solid is showing up, and my bracket is ready to be assembled and oriented into the correct position. I also, while I'm working here in the structure tree, want to turn the solid block into a component. So I'll right click on solid, click move to new component, and I will name this block, and then click. And I have now defined my block as a component as well. These surfaces are the two surfaces that I used to generate the holes for my bolts, and since I won't be needing them, I can go ahead and right click, delete, and remove those. This F7209 is the actual part number for the bracket. It's a little bit confusing, so I'm going to right click, rename, and label this as the bracket. Now I'm ready to begin the orientation. To do the orientation, I will use the Align tool, which is found under the Design tab. So I go to Design, Align, and I click off of the screen or off of any parts to make sure nothing has been selected. Now I come, and the first face that I pick will be the face that moves to the second face that I pick. So I'm going to click the inside face of this bracket and then click this front face of the block, and you can see that this face now has rotated to my block. It happens to be in the opposite direction that I want, so I will come here to bracket, right click on Align, and click Reverse Sense. And now the bracket has been moved to the front of the block. You can see that the holes are not aligned correctly, so that will be my next step. So I come to Align, click off the structure to make sure nothing has been selected. I'll click on Pan and left drag this body more into the center. Click on Align, and now I'm going to pick this outside circle of the bracket, and I'm going to align that with the circle that initiates or is the start of the bolt hole. And you can see my bracket moves to that position. Now I'm ready to click on Pan, left click and drag the structure up, click on Align, click off the body, go click the next hole on the bracket. So I'll click there and then click the inside or the actual cylinder, and now my bracket has been aligned to my holes. You can see my align commands that have been developed. To verify this, I can look in the Z direction, and you can see that my through holes go all the way through. I can rotate it around, and by looking in this direction you can see that the holes are the same size as the holes in the bracket. So now I'm ready to go ahead and pull into the model the bolts, and I can do that by the same approach we used before. So here's my body. I can pan and drag it in, make it a little bit smaller, go to File, Insert, File, and now I want to back up one directory and look at the bolt. So double click there and click on the IGES file and click Open. and this has now brought my bolt into my structure. Again, I want to right click on the bolt and click geometry. You can see down here it says no geometry problems were found. Now I want to activate it and get these check marks in it, so I click on the box out in front of the bolt and I click on it again, and now I can open it up and see that my bolt appears as its own component, just like these other components. Now I'm ready to align my bolt. To do that, I'm going to click on the bracket so that I can no longer see the bracket, such that it is hidden. Now I'm going to zoom in a little bit, and I'm going to click on the Design tab, go to Align, and I'm going to click on the bottom face of the bolt head, and I want to align that to the front of the bracket. So I now need to turn the bracket back on so that I can see it, and click this top face where my bolt will be aligned. Again, you can see that that bolt has been aligned in the reverse direction, so I will come to the bolt, click Align, and reverse the sense, and now you can see that the bolt appears to be at least in the proper direction. I now want to move this bolt and align it with the top hole. It's a little more clear on the back, less geometry in the way, so I'll actually rotate to the back and use my scroll button to scroll in. I'll come to the Design tab, Align, click off the structure so that nothing is selected. I'll come and select the axis of the bolt, and then I'll come and select the axis of the hole. And you can see now that the bolt has moved to the top hole. Now it would be nice to simply copy this bolt and move it down to here, but if you look at this, that can't be done now because the bolt has been placed inside a hole and it's restricted its movement. If I come to Move and click on the bolt as the geometry, you can see that it's fixed in the rotation, and that's the only way that I could move this particular bolt is through a rotation. These other dimensions are fixed because it's fixed in the block. So I'll come back and I'll actually insert another bolt. So I go to Insert, File, and click on the bolt again, Open, and I essentially do the same process. I will uncheck the bracket so it can't be seen. I'll go to the Design tab, click Align in the mini menu, click on the bottom surface of the bolt head, go back and turn my bracket on, and click this front face of the bracket. I now need to go to my new bolt and double click on it, go to the Align, right click, reverse sense. Now I can rotate again to the back, and I'm in Align, so I will click the center line of the bolt, come down and find the center line of the hole, click it, and move my bolt to the hole. I now have my bracket and my bolts loaded into my geometry. The only thing I have left to do is to include the nuts. So I'll come to File, or into the Insert tab, click on File. Now I'll go to Backup One directory and click into my nut directory where I have the IGES file for the nut. I'll click on it and open. You can see that it is open down here. It's hard to see there because of the other components, but if you clear it, you can see the nut head down in there. Now I need to align it after I've checked the geometry, so I'll right click, check geometry. Again, no geometry problems were found, so I can right click on it and get the check marks. I can open the down arrow, and now I have that solid in there, and I'm going to go ahead and hide my bracket again, so I'll uncheck it, and now I'll rotate this around, go to the Design tab, click Align, and I'm going to pick the back side of the nut select it, rotate my body around and move it so that I get to where I want to orient and assemble my nut. So I'll click on this back face. You can see now that it has moved, it's aligned my nut with the back face, but it's certainly off of the axis. And you can see that if we zoom in closer, it's aligned such that I'm going to need to reverse the direction of the alignment. So I'll come to the nut, down to the align, right click, and reverse sense. Now you can see that the nut is aligned with the right face of the bracket. I can rotate that up. I'll actually zoom in a little bit, pan, and move this down. You can see I got this could not create assembly condition because I was panning while in the align tab. So since nothing was created, it's fine. I will click off my body now. Now I'll come and rotate this a little bit more. I will click the axis of the nut, come over and click the axis of the bolt and align the nut. One thing I could have done, which I will actually do now, is I will undo that command, and before I move the nut to the bolt, which would fix it from being able to be copied, I'm going to go ahead and click move and click the body of the nut, click on this vertical axis and push my control button while clicking and generate another nut. Now I can come back to the design tab, the align, click off the body, and I'll click the center axis of the nut and then come over, find the center axis of my bolt and align that nut to that bolt. Then I'll come and click the center line of the bottom nut and align it to the center line of that bolt. Now my body has been created. It looks like I'm missing my bracket, but that's simply because I've clicked it to be turned off. I can come back up and click my bracket on, and I now have my system built. My cantilever beams in, my bolts are in, and my nuts are on, and my bracket has been designed. I'm now ready to move this into Ansys Mechanical and continue to develop the model. To do that, I simply minimize this window and double click on Model. After opening Ansys Mechanical, I can see that my object has been brought in. I can click my middle mouse button and rotate the object to make sure that it looks like all parts have come in correctly. If I want to go back to that isometric view, I can hit this sphere down on the coordinate directions and it'll take me to an iso view. I can come over and open my geometry drop down, and I can see all of these solids have been brought in. They have different names here, and I can tell what type of a body it is by what's given after the slash where it says solid 1. I'm going to rename these. I know they're all solids, so I'm simply going to make names that are a little easier to follow. So I'll click on the body or click on the title, the name in the drop down, and then click F2 and I can change the name, and here I will just type in block, enter. Then I'll click on the next one. It will highlight the geometry in my project window. I can then click F2 again and type in a new name, bracket. Down here I'll click on the bolt and I can right click and then click rename, which does the same thing as F2, and I'll call this top bolt. The next one here will be bottom bolt, and then I have the nuts that I need to rename. This will be my top nut, so I'll click on it, then F2, top nut, and my next one here, F2, will be bottom nut. I can go back to an isometric view And I have renamed all my geometry parts. In terms of things that need to be corrected, the only one that I often change is the behavior. So over here under behavior it says program controlled. Oftentimes I will make this a symmetric contact, which means the surface and the target both act as a surface and a target. So that has fixed that contact. We're ready to move on to the next one. This next one shows a contact between the bolt and the inside of the bracket. We certainly need that contact as well. I will click F2 and rename this to top bolt to block. And then I won't go and change any more details. I'll come down here to my next contact and click F2, and this will be bottom bolt to block. And then I'll look at my region 4, and this is the bottom side of the nut to the back side of the block, and I certainly need that contact as well. So I will click on it and then F2 and change that to top nut to block. Region 5 will be bottom nut to block. Now when I look at contact region 6, this is the inside or the bottom of the bolt head to the front face of the bracket. And I certainly need that contact as well. So I will come here and click on that and click F2 and then rename it as top bolt to bracket. I will come down to contact region number 7, click F2 and go bottom bolt to bracket. Now with careful review of these contacts, I need to see if there are any other contacts that are missing, and I don't have a contact currently between the bolt, the outside of the bolt, and the inside of the nut. And the reason Ansys didn't generate one is because there's a very small gap in the geometry between the inside of the nut and the outside of the bolt. And so Ansys didn't realize that those two members were in contact. So to create a contact there, I come to Contacts and I right click on Contacts and I come over to Insert and then click on Manual Contact Region. And when I do that, it brings up details of the contact. It's asking for me to select the geometry for the contact. I'll click the outside of the bolt and then I can click on No Selection and click Apply, and it says I have one face, and now I have that show up in my contact body view. I can now come up here and I can click on that body, and I can then right click and say Hide Body, and I can look inside of that nut. And looking inside of that nut, I can come to the face selector and select the inside of that nut, come to Target, click on it, click Apply, and I now have the contact body is the top bolt, the target body is the top nut, the type is bonded, and this makes sense to have a bonded type here because the threads between the two would act very much like a fixed type of bonding unless I was looking for particularly the stresses in the threads. Then I would probably want to look at this in finer detail. But for the model I'm developing, a bonded contact is great here. In terms of behavior, I'm going to go ahead and do a symmetric pair again. I'll click on the name and then I will F2 and I will change this to top nut to bolt. Now I have to come back up to Contacts and right click and Insert Manual Contact Region, and here I will click the bottom bolt on the outside and that will be the contact. I'll click Apply. Now I can come up and click on it again and then right click and go Hide Body. Then I can click my surface tool if it's not already selected and click the inside surface and then click on Target and Apply. Coming back down here, I will change the behavior to symmetric. Now I'll come back and change the name on this one and F2 and I'll name this bottom nut to bolt. Now I have all the contacts that I need. However, I need to be careful that up here I didn't change all the detailed information in some of these. And so to do that all together, I can come and click the top one, shift click the bottom one, and I'll make all of these frictional contacts. So I'll click on frictional and I'll give them a friction coefficient of 0.2, enter. And now I changed all of those contacts together instead of having to do it one at a time. I can also come and change the behavior to symmetric pair. So just double checking, I can check my top one and I can see that I have a frictional, a 0.2, and a symmetric pair. Then my next one, I have a one face and then the two faces on the target, frictional, 0.2, symmetric pair. And I can go down through and check all of those to make sure that my contacts are like they should be. The next thing I want to do before I leave contacts is come up to my contacts and I click on Connections, and then I come over and click on Contact Tool. This here shows all of my contacts, and what I can do is a validation of my contacts before I actually solve my model. So I can come to the Contact Tool now that I have it inserted, and I can right click and then click Generate Initial Contact Results. And this will take a minute because it actually comes down and meshes the structure and computes to make sure that the contacts are working as they were defined. If you had received an error, you would get messages down here on this worksheet. Since our worksheet is blank and we have the ready signal down here in the corner, we have validated that our contacts are all valid and we're ready to move on with the remainder of developing our model. With the connections finished and the contacts developed and tested, it generated a mesh when we checked and to validate our contacts. So this doesn't appear to be the best mesh, but the focus of this tutorial is to import CAD and look at contacts. So we'll go ahead and just accept that default mesh. I'll come to static structural and enter boundary conditions. I'm going to enter in a fixed support on this top face and then as well on the bottom. So I click fixed support, click the top face, then I rotate my body and control click the bottom face, and then I can click on apply, and I have two faces and my fixed support. Now I'm going to apply the load. The load that I will apply will be a force, so I'll click on force and I'll apply a force to this bottom face, and then I'll come over to the details of the force, click apply. I have one face. I don't want to enter this in as a vector, I want to enter it in as components, so I'll click on the box defined by and change vector to components, and then I'm going to enter in a negative y component of -100, and just for fun I'll enter in an x component as well, and we'll put 50 in the x direction and enter. So I'll use those as my loads and my boundary conditions. Now I come to solution and I'll look at deformation. I'll look at the total deformation. I'll look at stress and I'll look at the equivalent von Mises stress. I can also look at stress and come down and do a maximum shear stress, and I could do a normal stress. So now my body has boundary conditions defined. It has the output results that I'm looking to determine. I can go ahead and click the solve, and you can see that my solution is being processed down here by the green indicator showing the progress of the solution. Once my solution is finished, I got green checks by everything. I can come and look at the total deformation, and it makes sense that the deformation is the largest on the end of the cantilever beam, and so my deformation out here is the largest. The deformation of my block is pretty solid. I can look at the equivalent stress, and I have largest stresses around the holes where my bolt goes through. Looking at my geometry, I can see that I'm missing my bolts, so I can actually come up to geometry, and I can see that from when I define my contacts, I haven't turned the viewing capability on these bolts back on, so I can right click and then click show all bodies, and then I have my bolts. I can come back to equivalent stress, and I can see the bolts now in my equivalent stress plot. I can look at maximum shear stress, and I can also look at the normal stress. If I come back up here to total deformation, one thing that's kind of nice to sometimes look at is an animation of the results. You can come down here to animation and click play, and you can see that your beam deform due to the loading that you have applied. And this is often helpful to make sure that the deflections that you are applying or the loads that you're applying give you the correct deflections, and that the load path can be validated. So this looks like what it should with the loads that we gave it. This beam is very stiff in the up and down direction, so we have a lot more motion in the X direction than we do in the Y direction, based on the loads that we gave it. I hope this tutorial has been beneficial for you.